So the next topic to discuss is going to play off of atoms, essentially. So now we have an understanding of what atoms are. We have an understanding of what matter, compounds, and molecules are. I think it's a good time to start talking about what an ion is. And in this lesson, you will learn a good general understanding of what an ion is. So I want you to remember a concept that we have talked about in the last lesson. So here we have a picture of an atom. What is an atom? Well, we know that an atom has these subatomic particles, and it has three subatomic particles. In the nucleus referring to the center here, we have a proton and we have a neutron. Now, it's important to know that neutrons are neutral, meaning that they don't contribute to any charge, not positive nor negative. They're just neutral. Now, protons contribute a positive charge. They are positively charged particles. And then on the outside, we have, spinning around the nucleus, the electron. And the electron is negatively charged. And we're going to discuss what it means to have these particles and how that relates to what an ion actually is. So to talk about ions, I'm just going to pick an atom. And at random, I decided, hey, let's go with fluorine. Now, I'm going to explain to you that this is an element, so as you remember, elements are different types of atoms, and a fluorine atom, this is one atom. You can see how we have a center here that's consistent of protons and neutrons, and on the outside are electrons orbiting it. If we were to count the number of protons and electrons, what do you get? You get 9. You get 9 protons and you get 9 electrons. Now, in the next slide, I'm going to explain something here. So now you're about to learn what the definition of an ion actually is. But let's preface it with some information. So we had fluorine, right? And I talked about how fluorine had 9 electrons and it had 9 protons. So what's the difference between 9 electrons and 9 protons? That's a difference of 0. They cancel out. There is 0 difference. We don't have 10 electrons and 9 protons. That'd be a difference of 1. So, since there is no difference, we have 0. And when you have a 0 difference between your electrons and protons, when the electrons and protons actually cancel each other out, the charge is 0. And when the charge is 0, that means the atom is neutral. And now, in the next slide, you're going to see what an ion actually is. So I want you guys to follow me here and just hear me out. We're about to tell you what an ion is, and there's 2 types of ions. And the first type of ion I'm going to talk about is an anion. Now, what is an anion? It's a negatively charged atom. So let's look at our fluorine atom, the one to the left. Remember this fluorine atom? It was neutral. Why was it neutral? It had 9 electrons, 9 protons, and they cancel each other out, because that just ends up being a difference of 0. So what happens if another electron were just to come ahead and attach itself onto the fluorine? Well, this is what an ion is. An ion is when that balance goes away, when there's no more balance between protons and electrons. The difference between them now is not 0. The difference between them is now 1. Now keep in mind, this is an anion. Remember that electrons are negatively charged. So an anion describes what happens when there is more electrons than there is protons. And when there is more electrons, then it's going to become negative. And that's why we now have a fluoride ion. And as you can see, the fluoride ion is called F-. So the difference between this is now -1. It's not just 1, it's -1. Why is it -1? Because we have 1 extra negative electron. One more than the proton, so that's -1. So that's what an anion is. Now, the next ion to talk about is a cation. So if an anion is a negatively charged atom, I think you should know what a cation is going to be. So the last topic is a cation. Now, we had an anion, which was a negatively charged atom. Here we have a cation, which is a positively charged atom. Now, the important thing to note is that the thing that changes in atoms to create an ion isn't the proton. And you can see it here. If you look at both pictures, you notice the only thing that changes is the number of electrons. That's something I didn't explain yet, and now I'm going to explain it to you now that I've shown you both types of ions. Ions are essentially created by the addition or subtraction of electrons, the adding or gaining. The protons don't change. Now, you're probably wondering, why the electrons? Well, you could kind of intuitively guess. If you looked at the structure of an atom, as you could go back actually and look at the picture that I have on the video, you see that the atom has this tight core of neutrons and protons. They're not really going to want to separate or move. They're kind of tightly bound in that nucleus. But if you look on the outside, you have an electron, and you can't see it in the picture, but that electron's constantly moving. It's moving around the nucleus. And since it's moving around, we like to call the electron a mobile carrier of charge, because it can move. And since it can move, it means it can move to and from other atoms. So in the case here, we have an atom of sodium, and its electron on the outside moved. So that electron is now lost. And since we lost that electron, we no more have that zero net charge. There's no zero, there's no canceling out. Now we have 11 protons and 10 electrons. And since we have one more proton, and since protons are positively charged, we have +1 net charge. And that essentially is what a cation is. A cation is an atom that loses an electron and becomes positively charged, because now there is more protons. So this is what ions are. They can be split into cation and anion. So a final point that I'd like to bring up to you with ions is I always like to bring up a real-world example. Now, why should we care? Well, if your goal is to be a scientist, or your goal is just simple curiosity, science really explains why things are the way they are. And I can explain to you why salt is even salt. That's because of ionic bonds. Now, we're not going to go too in-depth about ionic bonds, because I believe that the background information needed, we haven't gone to it yet. This really requires you understanding the periodic table and something called valence electrons. So I'm just going to explain what ionic bonds and ions, how they can contribute to something in the real world. Well, look at the picture on the left. Let's start with that. We have an atom of sodium and an atom of chlorine. Now, sodium has an electron that it would like to give, and chlorine has a space that it would like to have taken by an electron. So this reaction between sodium and chlorine is going to make two ions. Now, sodium is going to give up its electron. Sodium is going to lose the electron, and chlorine is going to gain sodium's electron. So what do you think happens? Well, sodium lost an electron, so now it becomes positive because it's going to have more protons than electrons. So now we have a sodium cation, and chlorine is going to become an anion. It's going to become negative because it just gained sodium's electron. And now this occurring is what creates sodium chloride. This is how an ionic bond occurs. And this ionic bond is exactly what creates table salt, something you probably have every single day. And this is why science is so fascinating, because it can explain these physical phenomenons. Why is salt salt? What is this? What is this thing that we have to eat every single day? Well, that's good old thanks to ionic bonding. And that's a great place to end on with ions. I'm thinking that next lecture I might start talking about the periodic table so we can go into some more in-depth topics. So thank you for watching, and I hope you learned something.